So today we're going to be working through the Edexcel Further Statistics 2 AS exam paper. So this is for the first year of study. This isn't the second year exam. So this is the shorter exam. There's only 4 questions, so quite a quick paper overall. So question 1 is looking at Spearman's rank correlation coefficient. And then part A just actually wants us to work out the SRCC for part A. So to do Spearman's rank, remember the clue's kind of in the name, right? We've got to rank the scores. So what we've got here is basically a skating competition, and the scores are judged by 2 different judges. So what we'll do is we'll do judge 1 first, and then we'll rank judge 2. So we're going to start from smallest to biggest. So my smallest is just this 53 here. So I'm just going to do it above. So that's rank 1. My next one is 57, so that'd be 2. And this is all you've got to do for the beginning. So my next one is 61, so that's 3. 62, that'd be 4. 63 would be 5. 70 would be 6. And then it'd be 71. And then 72. Okay, so them are the ranks for judge 1. And obviously you've got to be very careful that you just get these in the right order. If you get this wrong, your Spearman's rank correlation coefficient will come out probably wrong as well, unless you get very fluky. So let's do the same for judge 2 now. So my smallest one here is my 52 here. So I'll do the ranks for these ones underneath. So that's a 1. My next one's 53. And then just do this the same for judge 2. So my next one's 56. And I don't think there's any mistakes there. 8, 7, 6, 5, 4, 3, 1, 2. That's perfect. Okay, so we've ranked the 2 judges' scores. Now what we need to do is work out d squared. So d squared. So to work out d squared, well, you've got to look at the ranks for each score. So this is 7, this is 8. So to work out d squared, all you do is subtract here and then square the value. Now, it doesn't matter which way you subtract, whether you do judge 2 minus judge 1 first or judge 1 minus judge 2. Because you square the d, it'll always be positive, right? So it doesn't matter which way around. I'm just going to do it as judge 1 minus judge 2, but like I said, it does not matter. So 7 minus 8 would give me minus 1, and then square it. So I'm going to get 1. So what I'll do is I'll just write them all along here. So the first one's 1. 6 minus 7, square it, that'll be 1. 8 minus 6 and square that, that'll give me 4. 4 minus 5, square that, I get 1. 5 minus 4, square that, I get another 1. 3 minus 3 and square that, I get 0. 2 minus 1, square it, I get 1. And then finally 1 minus 2 and square it, I get 1. Okay, so these are my d squared values. So just do them over here. D squared. Okay, so I probably should have done it underneath, but these are my d squared values. So let's add these up. 1, 2, so that's 2, plus 4, 6, 7, 8, 9, 10. So the sum of d squared is equal to 10. And that's important because this is part of our formula. So you don't have to memorize this formula, guys. It is in your formula book. But the formula for the correlation coefficient is going to be 1 minus, it's 6 lots of sigma d squared all over n times n squared minus 1. Okay, so this is in your formula book. So let's use this formula now using our d squared here and our n. So n is a number of ranks. So we've got 8 different ranks here. So n is going to be 8 as well. Okay, we've got everything we need now. All we've got to do is just plug this into the formula. So it's going to be equal to 1 minus 6 lots of 10, because sigma d squared is 10. And then we divide it by n times n squared minus 1. So that's times by 8 times 64 minus 1, so 63. Okay. Oops, sorry, I've kind of messed the formula up here. So if I just erase that line, the line should just be underneath here. So it's 1 minus this quotient here. So 1 minus 6 times 10 over 8 lots of 63. Plug this in on your calculator, and what you'll get is 0.8809, which if you round it, will give you 0.881. And there we have it. So that is the Spearman's rank correlation coefficient for part A. So that's part A. Part B, I might have enough just to do it down here. So part B, we actually have to do the test now. So we're testing at the 1% level of significance, whether or not the 2 judges are in agreement. So for any hypothesis test, we need our hypotheses. So H0. Well, because we're talking about correlation and it's Spearman's rank correlation test, again, we're just going to use rho. So rho. Well, we're going to test whether that's equal to 0. And then H1, we're going to test whether rho is greater than 0. Okay, so that's going to be your hypothesis for this one. Now, we've got the test statistic. This is 0.881. We need the critical value. So test statistic 0.881. Critical value. How do we get this? Well, just use your formula book. So we're going to look on the page which has the correlation coefficient. Now be careful because there's also the regular test here as well. So make sure you do Spearman's rank correlation coefficient test and not PMCC. So for this, n is 8 again. And remember, you're going across from 0.01 because it's a 1% level of significance. So your critical value, if you're on the right page, you should get 0.8333. So because the test statistic is bigger than the critical value, we're going to reject. So therefore, reject H0. Reject H0. So there is evidence. There is evidence to suggest the two judges are in agreement. Okay, so that's part B done, so reject H0. And then finally for part 6, we just clear everything else. It just tells us that Judge 1 accidentally swaps the scores for skaters D and E. So the score for skater D should be 63 and the score for skater E should be 62. So what you've got to think about here is just switching these around. Now, if you switch these around, well, what would happen is you'd have your 62 here, so that'd be your 62, and this would be your 63. And what actually happens because of that is because when you do the subtraction here, this would give you a D squared of 0. Now, because that one becomes 0, what happens now because of this is that the sigma D squared is smaller. So if we do it over here, actually, part C. So sigma D squared becomes smaller. Now, because this becomes smaller, something happens to the correlation coefficient. Now, if you're unsure, just do a practice with this. I know it says don't do any further calculations, but you don't have to show that. Just make sure you understand what happens. So you could change this. For example, you could change your sigma D squared to 7 and then do 1 minus 6 times 7 over 8 times 8 squared minus 1. Test that, and what you'd find is that the correlation coefficient becomes larger. So becomes smaller as the 62s align. So because of that, the correlation coefficient will increase. And there we have it. So that's question 1 for the Further Stats 2 exam fully complete.